So you guys won't even be here tomorrow, right?
Right.
And then on Wednesday, what do we got? 9 weeks test. Somebody mentioned not knowing where the review was. The old book that all the reviews are in. If you go to Schoology, in Schoology, there's a black folder that says prior semester, whatever. When we're done with this section, I just throw it in there to kind of keep it cleaner on Schoology. So since we're already in the fourth 9 weeks book, that third one is in there, but just open up that folder and you'll see book third 9 weeks in a purple folder, and just, I would probably not hit print all, but you certainly can print those review sheets again and redo them. Some of you might go, man, I got a good area. I know this stuff. Well, then maybe just go through the keys. If you're looking at something to study, go through the keys and just look over the keys. If you struggle at all, looking at my work is not the best way to do well. It's like that Chinese proverb that you hear and you forget, you see and you remember, but you do and you understand, right? So doing the work is going to help you understand it the best. But again, if you have really great grades and you don't forget stuff, then maybe just a quick review would help you. All right. And again, if you make an A or B on it, even a really low B, 80, I'll drop your lowest test grade. So some of you guys have really good grades, but you got one stinker that was in there that's just dragging you down. Well, it will just vanish with an A or a B. As long as your A or B is better than your lowest, I drop your lowest. All right. Okay, so let's talk about area. Area formulas don't really need this. Let me close all this junk up. So area of a triangle. We actually have already proven one of these, but we'll do it again real quickly if you forget. And we're looking for area when I give you information. Now, ultimately, guys, if you knew one area formula, you'd be okay. But you might have to find a whole bunch of more junk to fit it in, right? If you had one area formula that would work great for side angle side, well, if I gave you side angle, I guess you could find enough information to go into that side angle side formula. Actually, that's what you have to do anyway with side angle. But with other situations, you could find more information and stuff it in that one formula. But I'm going to show you formulas for every situation except side angle, which is continuing to be a pain in the side angle. But sorry, I tried to come up with a formula, and there is one. I mean, you can make a formula, but it's not worth remembering. By just doing substitutions, it becomes this monster. So here are the formulas. We're going to want one for side angle side. That's the first one we're going to deal with. We're going to talk about what you do if you're given two angles and a side, whether it's angle side angle or angle side. And then we'll talk about what to do if I give you side. You should already know that one. It's called Heron's formula. You should have learned that geometry. And if we have time, I want to show you the proof of the Heron's formula, because it is an algebraic wonder. Like the guy who came up with this formula, he did this series of substitutions to kind of clean it up and make it look really nice for you guys. And it's not like it's rocket science. There's much more incredible proofs out there that prove things, but this one was, again, it was an algebraic wonder, the way he manipulated everything and used the semi-perimeter to kind of clean everything up. I've always thought that was interesting. So let's talk about these one at a time. The first area formula everybody knows of a triangle is what? 1/2 base times height, right? And that's great if you have a height, but in the situations we have, we normally don't have heights, right? We have sides. So if I'm missing a height, I'm in trouble here. So what I want to do, and again, this is base and height, and your book uses, you might have noticed this, they use K for area. Kind of annoys me for some reason, so I always use the word area. But don't use A for area, because we're already using A for angle A. All right, so the area of 1/2 base times height, let's talk about that. So let's just say we have this, and I know some sides here. In fact, let's make it just a pure side. Let's just say I know these three. So side, angle, side, right? So I'm trying to use this formula here. So I'm going to try to find the height. I know the base, right? The base is B. So I've already got that, but I need to find the height so I can find this area. So how do I find height if I know this angle and this side?
Law of sine? Or
Again, I just want a quick formula. All I need to do is find h. Can I do that? Now that I've kind of created a little right triangle in there, what trig function do you know that allows me to find h? That is true, but we only know these three pieces of information, right? So you could use sine of A is h over c. So if I said, well, sine of A is h over c, then I could multiply both sides by a c, and I'd have my h value, right? And if I replace h with c sine A and base with b, I've got an area formula. So 1/2, the base is b, and then c sine A. Well, that looks like anytime I have side, angle, side, I can use this formula. So side, angle, side, first area formula, 1/2 BC sine of A. Guess what the other two are?
AB sine of C.
AB sine of C.
BA sine.
A.
AC sine of B.
C sine of B. And that's side, angle, side. Does that work if I give you this? A is 10, angle C is 12, C is 7. Does that work? No, because this is not side, angle, side. What's this?
Side.
How do you know it's side, angle?
Because C.
They're not all different, right? You got a matching set right here, and if you drew the picture out, you can see it, right? C, and A, that's side connected to side, then connected to the angle. So I can't plug that in there. You can see that it won't fit. Every year somebody tries to make it fit. Don't try to make it fit, guys. We're going to have to do something else if I was given this situation. All right, so anytime I have SAS, boom, plug in that, you're golden. Now, what if I don't have SAS? Now, some of you are thinking, well, I guess just get busy and find more stuff. Like if I was given angle, angle, side, or angle, side, angle, clearly I can't fit that in there, right? I can put part of it in there, but I'm still missing stuff. So one thing you could do if you were a glutton for punishment and didn't want to memorize anything, you could take this and solve the triangle, right? Find another angle and then find another side. By the time you find the third angle and another side, you'll have two sides and all three angles. That'll certainly fit in here, right? You'll have two of the sides and all three angles, so you can make that fit. If you want, you can do that. But to do that, you'll have to plug some junk into the law of sines and solve for that other stuff. Well, somebody thought, well, if you're going to plug it into the law of sines, why don't we just take the law of sines and use it to make a new formula? So literally, they did this. They took sine A over A and sine B over B, and they solved for a side. Doesn't matter which one. Check it out. Cross multiply, or how about this? We'll solve for side B. I'm going to slide B up, slide A up, slide sine of A down. So I get B equals that. Now I'm going to replace B with that. Check it out. Right here. So I'm going to take that formula down. 1/2 my new B, A sine B, actually, sorry, not there. I'm going to plug it here. 1/2 A times my new B, which is A sine of B over sine of A times sine of C. Now it looks a little ugly, but look how nicely it cleans up. When I simplify that, I get area. I'm going to put area right here. I'm using this formula. When I do this, I get 1/2 A squared. And then I get this fraction that has sine of B and sine of C on the top and sine of A on the bottom. So think about it. If I give you two sides and an angle, what are you always able to quickly find? The third angle? So basically, when I give you two sides and an angle, you really kind of have, right almost immediately, all three angles in a side. So take the side, plug it there, plug the angles here, just make sure the angle opposite that side is with the sine on the bottom. The other formulas are 1/2 b squared, but you'll see they have sine A and sine of C on the top and sine B on the bottom. And the other one is 1/2 c squared, and you'll see sine A and sine of B on the top with sine of C on the bottom. So whatever side that I have, plug the side there, square it, and make sure the sine of that particular side's angle is on the bottom, and the other sine of the angles are on the top. Then, of course, don't forget the 1/2. Right? And again, I wanted to save this for last. And then the last situation is side-side angle. Side-side angle doesn't fit anything. So you tell me, what do you do? And you have all these formulas somewhere in your work, like the area formulas. So in case you copy them down wrong, they all are somewhere in the book. Look at the table of contents. I think you'll find it. Now, if you have, think about it. If I gave you side-side angle, here's an example. B is 10, A is 9, angle B is 36 degrees. That doesn't fit in here. Look, side A and B, oh, I need angle C, right? Side A, oh, I need a whole lot more, right? I need two more angles. They don't fit. And Heron's formula that works for side, 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 I still need a side, don't I? So what would you do if this is all you have? And remember, you do have this formula, Heron's formula, which I'll show you in a second, which if you remember was the square root of S times S minus side A times S minus side B times S minus side C, where S is the semi-perimeter, half the perimeter. And by the way, if anybody ever asks you for Heron's formula, don't just give them this. Is this, what is S? Right, it's a two-part formula. So tell them that and then say when S is this. So if you had this, what would you do first?
You could do law of sine and find the length of B.
So you'd have to use law of sines to find another side, right? So, well, you already know A and B, but you mean the angle what? Use law of sines to find what?
Find the angle of A. So.
Angle A. So check it out. You go sine of B, which is 36, over B, and sine of A over the 9. And then you'd have to just do your math, do your stuff to find angle A, right? So I'm going to just walk you through this quickly, make sure that you're in good shape. So right here, I would say you would end up having 9. $31 point, call it 9. Now guess what? It's still not enough to go in any of these formulas. What would you do next? So I could add A and B and subtract from 90 to find angle C. So, or I'm sorry, add A and B and subtract from 180, right? So 180 minus the 36 minus the 31.9. Now at this point, once I do this, now what? That gave me angle C is 112.1. Take a look at what I have. I have all the angles in two sides. Do I have enough to go into one of these formulas?
Yes. Angles.
I could do angle side or side angle side. I personally am a fan of the side angle side formulas, but you're going to have to find that last angle, both those angles, to do either one, right? But once I find this very last one, I'm just going to grab the A and the B and the C, and I'm going right here. But if you want to grab the A and the ABC, or the B and the ABC, you could use either of those. And if you're a real big sucker and you love Heron's formula for some reason, I guess you could do more math and find side C, which is going to be an ugly decimal, but you could. And that ugly decimal, of course, is going to show up in your semi-perimeter. It's also going to have to be subtracted there. So you're going to have ugly decimal, ugly decimal, ugly decimal, ugly decimal, ugly decimal. Why do that? But you can. You tracking with me? All right, so those are your area formulas. For any, if it's a right triangle and you know that, well, go 1/2 base times height because you have the base and you have the height. Those are the legs, right? But if it's not a right triangle, you can't do 1/2 base times height. You can't do Pythagorean theorem. You can't do your regular trig functions. You're going to have to know these. And if you want to memorize them, knock yourself out. Nope. Take note, though, that it's not like I did a ton of math. I did a little height, if you forgot them. I mean, granted, if you don't know them on your test, you very well may run out of time. That could be troublesome, but I'm hoping you know. But worst case scenario, you forgot, say, this group right here, you could just take this and use law of sines to find a little bit more information. Take your side angle side step, find a little more information, you're probably okay. All right. Heron's formula. So the side formula. I don't know, maybe I'm making too much of this, but I've always been fascinated with people's algebra skills when they really have some skills. And plus you got to wonder, I mean, there are all these other formulas you could have used, but he spent the time to crunch this algebra to make it very doable. So I've always been a little impressed by this, but I want to show you this, and then we'll do a couple problems, make sure you're okay, and we'll call it a day. And remember, your 9 weeks test is when? Wednesday and Thursday, this test, and then Friday. Wait a minute, I'm getting backwards.
I think Friday was the test.
Sorry, Wednesday 9 weeks test, Thursday a review of not just the first part where you just took the practice quiz, but everything, right? And then test on Friday. And then I won't be here on that Friday, so somebody else will be administering this test. Unless I just happen to wake up and feel totally fine. Everybody keeps telling me I'm going to be like down for the count.
First day.
But you what?
First was fine for the first day, and she.
That's what I heard. Like middle of the night, you wake up and you feel terrible. I'm really hoping I don't. It's just the worst. Yeah. So everybody told me just you need to take the day off. So for some reason, my shot's on a different day than the rest of the population. I don't know why.
They're singling you out.
I know.
Special one.
Maybe they'll give me the good one. Anyway, everybody else had it like 4 or 5 days after me. That's why we're off on the 19th. But I had it on like a week before them or something. Anyway, whatever. And then you guys will just have to remember Pi Day. If you want it to not stink, start thinking it's that Monday. Start thinking if what you can do to bring that's individually wrapped. It's going to be the biggest mass waste of Ziplocs ever, probably. But anyway, be thinking about that. All right. Heron's formula. Let me show you this. Oh, let me find it. There we go. Okay. In no way, shape, or form do I expect you to like know this. Okay. I would have to sit down and really play a lot to actually to get all of it back. Probably mine would end up looking a little different, but okay. But let me just kind of walk you through it and see if you can kind of track what he's doing. Okay. Obviously, starting out with 1/2 BH. Okay. So he takes this triangle and he labels it ABC, right? And he puts a little height in there. Okay, and he says, and he defines the semi-perimeter as S equals A plus B plus C over 2. Right? So he's calling that S like we did in the proof. All right, and then he does some manipulations that we're going to come back to at the end. So check these out. See if it just makes sense. So the first one is he multiplied both sides by 2 and got this. Okay, so in the end, he's going to make a substitution. He's going to replace A plus B plus C with 2S, but just for now. Then he does this little clever thing right here. Let me explain these. So what he's doing is he's saying if 2S is A plus B plus C, then what if I subtracted 2A from both sides? So if I subtract 2A from both sides, what do I end up with here?
Negative.
Negative A plus B plus C. And then he factored a 2 out. Okay, so that's what's right there. Y'all see that? So he subtracted 2A from both sides of this initial one, and then factored a 2 out and got that. Well, then he did the same thing with 2B. Then he did the same thing with 2C to get these next 2 equations. You with me? Now, again, you're going to see these resurface in a while. Like, why on the earth would he do that right now? I don't know, but that's the genius of him thinking ahead on this algebra. So store this away from you, and then let's shoot off on another tangent. Okay, so back to this little circle ABC. He took the base down here, which was C, and he broke it up into 2 parts called P and Q. Okay? And then he said, all right, his height is, hold on. Okay, right. So area is 1/2 base times height. So 1/2 base is C times height. And he said, since P plus Q is now what C is, then he has 2 Pythagorean theorems here. He's got A squared equals H squared plus P squared. And then he's got H squared plus Q squared is B squared. He has these 2 formulas. And then he took those formulas and he said, all right, if P plus Q is C, kind of wish I could see all at once. If P plus Q is C, then Q is C minus P, right? And if I square both sides, then I get Q squared equals C squared minus 2 times the product plus P squared. All right? And then he said, I'm going to add H squared to both sides. Just randomly thought that would be a good idea. All right? And then he says, now I'm going to substitute this equation and get B. Hey, hold on a second. Why did he do the? Oh, yeah. H squared plus Q squared is B squared, and H squared plus C squared is A squared. Where did I write that down? H squared, right there. See it? H squared plus P squared is A squared. H squared plus Q squared is B squared. So he replaced the H squared plus Q squared with B squared and the H squared plus C squared with A squared. So now he's to here. All right. Now he's going to solve for that P value. Here. He's solving for this P value. So he's going to subtract the A squared, subtract the C squared, divide by negative 2C. And because the negative is there, he just basically multiplied the top and the bottom by a negative. So that would be positive. And that's why that's now positive, that's now positive, and that's now negative. You see that? Okay. It says now, since H squared equals A squared minus P squared, and that was written somewhere, since H squared, right there. Since H squared is A squared minus P squared, he's going to factor the A plus P and the A minus P, and then he's going to replace the P's. Since that's true, I'm going to factor it, A plus B, A minus P, and I'm going to replace each of those P's with that P value I just found right there. And then this is where it becomes a little bit easier to follow, but it's still nasty. Okay, so if I have A plus that, how would I add those 2 together? How do you add a fraction to a non-fraction? Common denominator. So you multiply this by a 2C on the top and a 2C on the bottom, which gave him 2AC. And now he's able to add that 2AC to that. And you can see that right here. And then right here, he multiplied that on the top and the bottom by a 2c, and now he has a 2ac minus all of that. So you see 2ac minus that, plus that. And then he took those two fractions and multiplied them together. I skipped that step, but he multiplied them together. So we got the top part of that, the top part of that, and the 2c times the 2c, which gives me 4c squared. Okay, now at this part, he got a little clever here. He said, well, this part right here factors into that. And he dropped down to b squared. And then he said, remember the 4-term polynomial where you group 3 and 1? Both of these ended up being that. Then he took this stuff right here and factored a negative out, and then factored it to right there. There's the negative taken out, brought the b squared down. And then he has a difference of 2 squares. So now that he has a difference of 2 squares, he factors that into that plus that minus b, that plus b. And then he changed the order. And then he said b minus that, b plus that, and changed the order. And then here, if you start recognizing these, right there, you recognize these from the very first page? So he left that alone. Or no, that was equal to the 2s. The negative a1 was the 2 with the s minus a. The negative b1 was the 2 with the s minus b. The negative c1 was the 2 and the s minus c. So he made substitutions with the semi-perimeter and factored all the 2's out, which gives me a 16 over 4, which is a 4, with one s, and then s minus a, s minus b, s minus c, and over just the c squared. And remember, all of this is equal to h squared, right? Well, if that's h squared, if I square root the top and the bottom, I get this. He factored the 2 out because he could. He gets this for the height. And then he went back to his formula and said, well, if the formula is 1/2 base, which was c times the height, I take that height, shove it in there, the c's cancel, the 2's cancel, and then there's my Heron's formula. Some dirty algebra. But anyway, makes it pretty great for side though, right? So that's your side. Certainly, I wouldn't expect you to know that, nor would I want to be held accountable to that as well. So let's just do a couple problems, make sure you're in good shape. First one, what if I told you A is 10, B is 12, C is 21? What are you going to use? And the question is, for all of these is going to be determine the area. Now, are you really? Yeah. So C is 21. What if I said C was 23? What would you use?
Same thing.
Would you? What would happen when you typed all this in your calculator? Your calculator says error. What would that
Is that
mean?
even possible? It means it's not.
No, it's not even possible, is it? The two small legs have to add up to at least to be more than the big leg, right? Or the big side?
If they're equal, does it mean?
If it's equal, it wouldn't be a triangle. But it would give you an error. I mean, it would give you an answer. It would just tell you the area is 0. But it doesn't make a triangle. To be a triangle, by definition, one side has to be bigger than the sum of the other two. Okay, so go back to 21. I'll tell you what, go back. We'll just make it 20. Make the math a little easier on you. So what do you need for Heron's formula? First, you need to find the what? The S, which is the semi-perimeter. So you have the lengths of the sides, 10, 12, and 20, all divided by 2, or half of that. So you end up with 42 over 2, which is 21. So your S is 21. So what is my area? The square root of what? 21 times what? 21 minus 10, which is 11, times what? 21 minus 12, which is 9, times what? 21 minus 20, which is 1. So if you had to clean that up, is there anything you could do?
3 root.
The 9 comes out, make that a 3, and then you have 11 times 21, which is what? 230, 231? You could write it like that, or if it's a test, you're going to have your calculator. You can type it in your calculator and just approximate to the hundreds or something. Right? Okay, what if I gave you this? A is 10, B is 12, angle C is 106 degrees. Find the area. What kind of a situation do you have?
You could do 10 times 12 sine 106.
1/2.
Or 1/2.
Don't forget the half, yeah. Because it's side angle side, my area, pretty quick, pretty easy to solve. 1/2 A, B, sine of C. By the way, y'all listen, hear this statement I'm making right here. Of all the formulas we've learned, what has a cosine in it?
The law of cosine.
That's it. None of the other ones have cosines in it. Every year I have somebody, and this I always find a little ironic, they use the law of cosines, but they use sine in it. Like, if it's going to be the law of cosines, you got to go with the cosine, right? They'll put sine in the law of cosines, and then they find cosine floating around in all these other formulas. All of them have sine in them with the exception of law of cosines. Law of cosines is the only one with a cosine. Well, and Heron's formula has neither. All right, so just straight up type it in your calculator. So 0.5 times 10 times 12 times sine 106, 57.68. And what are my units on this? I didn't say so. Unit squared. And if it does give you a unit, get in the habit of, like, if it's feet, write feet squared. If it doesn't give you that, then no worries. All right, what if I gave you this? Angle A, 32 degrees. Angle B, 88 degrees. Side C, 10. Determine the area. Oh, also on your test, make sure you read carefully. Sometimes it'll say solve the triangle. Sometimes it'll say determine the area. Don't find the area when you're solving, and don't solve when it says find the area. That's really frustrating for you when you get your test back and you're like, well, I knew how to solve it. I knew everything. I just didn't read. Make sure you read. It's hard to get partial credit when you find side C when I wanted the area, you know? Even if you show confidence in finding side C. So help me out here. What are you going to do? What kind of situation is this?
1/2 C squared.
What kind of situation is it?
Angle.
It's angle, side, angle, technically, because they're all three different letters, so the side's in the middle. But whatever. If you have two angles, you have what? You have the third one right at your fingertips. So how do I find angle C? Subtract what? 120?
Yeah.
So angle C is 60. And once I have that, what area formula can I go to? 1/2 C squared. And if I put the C squared there, where does sine of C go? In the bottom. So sine of the 60 goes on the bottom. And then you have sine of the 32 and sine of the 88 on the top. But that angle C and side C, make sure you get that placement right. So you go and you type in your calculator. If you ask me what I would do, I would just go 0.5 times 10 squared. And then I would go times sine of 32 times sine of 88. And at the very end, divided by sine of 60. That's what I would do. So 0.5 times 100 times sine 32 and the parentheses, except if you have an inspire, you don't have to worry about that, times sine of 88 and the parentheses. And do make sure you end the parentheses too. And then divide, let me show you what happens if you don't, times sine of 60. Check this out. What happens if I type in my calculator? Sine, and it automatically gives you this. If you have a cheapo calculator, I think. I don't think it gives you, I'd have to go back and look because I haven't used it forever. But people used to do this. They'd forget to end the parentheses, and then they just go divided by, and they do sine 60. Guess what your calculator does when you do that? It sines all of that. But it literally goes 88 divided by the sine of 60, instead of doing the sine of 88 divided by the sine of 60. So be careful with your parentheses if you have a calculator that needs that. You with me? So when I type all that in there, did y'all get 30? Anybody do this? 30.58. And again, units squared, if you were writing units. I'm not gonna count off if you don't, but it's good to have to get into. So we've done one of each formula, right? What about this? C is 10, B is 7, angle B is 28 degrees. Find the area. What are you going to do? What kind of situation do you have? You got side-side angle, don't you? Well, we don't have a formula for side-side angle. So what are you going to have to do?
Find the others.
Just start finding stuff, right? So the first thing you're going to find, just out of necessity, is angle C. So have you noticed anything about this situation, by the way? Ouch. That's brutal. It's an ambiguous situation. And if it's an ambiguous, well, all of side-side angle is technically, supposedly ambiguous. So if it's an ambiguous situation, and what do you know about angle C right here that you're about to find? It's going to be bigger than that, which means it's got a chance of being obtuse, right? So what does that mean you're going to do in a couple seconds? You're going to type this in your calculator, and what happens if your calculator gives you an answer? Then that means there are what? Two triangles here. And if your calculator says error, then you smile and say there's no area because there's no triangle, right? And if it happens to give you, well, it's no. So anyway, so right here to solve for this, you cross multiply or do your slide rule, multiply it out, then you do the inverse sign, and you end up getting, make sure you're able to do this with your calculator. I'm doing 10 sine 28 divided by 7. And that gives me a decimal. And then I'm going to inverse sign that decimal, and I get 42 point, I'm just going to call it 0.1 degrees. So my calculator gave me an answer. So that's angle 1, but there's also an angle 2. And how do you find that? Subtract from 180. So that gives me 137.9. Now, sadly, it's still not enough. I got two sides and two angles. What am I going to do with that? Find the third angle. So I'm going to go find angle A1. How do I find A1? Add this A and B and C. So I add that together and I get 70.1. So I subtract that and I get 109.9 for angle A. How do I find angle A2? Same thing, subtract that B and C, which that B and C, 14.1, a little smaller. Now do I have enough? Now I got enough. But if it's me, I love using the side angle side formula. So for my first area, BC sine A. B 1/2. B C sine of the A. Then for my second area, 1/2 B C sine of the A. Just easier than all that one with the three angles in it, to me. So for that first one, I get oh, I don't have it here. This is going to have a rounding error because I'm using a cheaper calculator. It's in this neighborhood. You wouldn't run around. You want to be exact, but I think it's in that neighborhood, and this one is in this neighborhood. Anybody get something different? But I'm using a rounded 109.9 because I did that in my head instead of doing it on my calculator. So it's not in there. But I would have been perfectly exact on my test. And that'd be the worst area problem I could give you. I mean, right there, obviously. What do you think?
Are you like copy of this on the Inspire?
Yeah. So let me just show you. So if you have an Inspire, it's pretty great. Nothing that you do ever goes away.
Is there a way where that's through?
Yes, I could show you that too. So here's my calculate screen. I can scroll up. Notice right here. Here's where I am right now. I'm down on this little spot, right? If I go up, it bounces from answer, formula, answer, formula, answer, formula. And it just keeps going up. I can go up forever. So hypothetically, let's just say I was trying to find the inverse sine, right? But I wanted to use this value that I did way up top. Well, just go up until you find the value that you wanted. Like in this case, if I had done it, I would have found 109.9, but it would have been exact, right? I just go up to highlight it, and when I hit enter, it takes that highlighted part and brings it down. So notice the 0.706 when I hit enter, bam, puts it in there. But it puts it in there, puts it in there exactly, so I never have any rounding issues, do I? You with me? The only thing that is a problem is, look, like let's just say I was doing a fraction and I had 5 over something, but I want to bring it down to the bottom. Well, look, if I go up, now I'm at the 5. If I go to the right, now I'm right there. In this case, look, if I'm trying to put it on the bottom and I grab it, it's not going to put it on the bottom. That's a problem. So in this case, here's what you do. You still have that answer key if it's the last thing you did. So you could just go control answer and bring it in, right? But if I had something else that I was trying to put in the denominator, so one thing that gives you trouble, if I had something else, then what I really want to do is this. 2 options. 1, just go up and grab that number and hit enter, and now it's your second answer. It's your last answer, right? So now I could do something like, oh, now I can go and just do the answer because now it is the last thing I just did. Okay? Or you could do this. You could go up and say you wanted that value. You could bring it down and you can store it. So the stow button right there, that's for store. You can hit control, store, right? So notice I'm going to hit control, store. Puts a little arrow there and it goes, what do you want to store it as? Pick a letter. Don't use X and Y because those are in functions. Don't use T either. X, Y, and T are bad. But A, B, C, M, N, P. Like if I chose to store it as A, I hit the letter A and hit enter. And from here on out, anytime I use the A button, it's going to do 60.26. And if I want to store over it, they just store A as another variable. But it'll keep that one just as long as the calculator's working. And if I ever want to clear all this junk off my screen, I don't know why you would, but sometimes I do if I want it just to look pretty, you know. But if you do that, keep in mind you're getting rid of data that you might want to use later. But if you know you don't want it, go to menu. Almost everything on this calculator comes through the menu. If you hit menu, if you look at actions, 1, I can delete variables. I can clear all my variables at once. I can clear history. So if you hit 5, it'll just clear the screen out. But again, I just got rid of all my history. Kind of like a little history in there, potentially, right? I might want to use that, but it will clear it out. And you ought to just play with it too, like things like number 2. You hit 2, you can change from to fractions to decimals, least common multiples. There's all kinds of things you can do with this that make it, that if you just bother to learn it. But the sooner you get it in your hand, and I know some of you parents are like, I'm buying that right now. But the sooner you get it in the hand, the better off you're going to be in this year and next year. Next year, we need them on day 1 if you're in here. So, and probably in regular Cal as well. I mean, regular pre-Cal as well, except that you don't have to have this particular version. All right, guys.
We're not going to see you at all tomorrow, right?
Tomorrow, you won't even be in the building yet.
Hey, Mr. Ray,
I completely forgot about that quiz. Can I still do it for half credit?
Give it to me more. Or by the end of the day, if you can squeeze it in. Dreading tomorrow. Giving a test, it's the worst. I know y'all think it's bad taking it. Giving it. It's mind numbing.
Can you take it?
No, that you don't get an extra copy. I kind of wish I could, but I'm not allowed to take it. I'm not allowed to grade work. I'm not allowed to read a book.
My instructor, for whenever we took that lesson, SAT, she was started eating halfway through. It was so funny.
Not allowed to eat.
They started eating. It was
Like
so
literally, I can't bring food or water in. I can't bring water because it might like be crinkled or something. Like like if you squeeze that bottle that he's got, it makes funny noises. Can't have any of that. I'll tell you what, man. ACT, biggest scam on the American people. Like, think about this. They created a company that everyone needs to take this test to get into higher education. You pay good money to take this test, right? And they don't even administer it. They get other people for free to give them their test. That's literally like having an auto body shop and saying, yeah, we have this auto body shop, but we're not going to fix your car. We're just going to give you a little manual and let you do it. But you're going to pay us.
You should take this to court.
It's unbelievable. But you have to take it. If you don't take it, can't get into schools. It is I wish I'd have thought of it. It's a huge racket.
Didn't they go bankrupt though?
Who?
Pretty sure they went bankrupt. Like
ACT?
College Board or something.
Well, that's AP. I don't know if they did or not. AP is different from ACT, I think.
Something happened.
College Board, there's another racket right there.
They're
Oh, you can get college credit if you do well on this test.
Their TikToks.
By the way, you're going to pay us $92 and we're not going to administer it. We're just going to send you the information and you can do it.
Their
What?
TikToks pop up on my thing, and they make me so mad. It's like this dude, and he's always like, "No, it's gonna be online," and I don't know. It just makes me mad.
Oh, that guy?
You know what I'm talking about? He's got like a little whiteboard.
Yeah.
Yeah.
For College Board?
Yeah. I want to punch him in the face. I'm not even taking any AC tests.
Is it telling us what's on the test?
Yeah, it makes you want to cry.
Some of the stuff they do is actually pretty good. I'll give them that. Like the videos they put out, stuff like that are really pretty helpful. Especially if you're a new teacher and you don't really know what's going on. I mean, literally, you could just put a video of them doing work the last 30 days of school, and your kids will probably get prepared. And you could sit back and do nothing if you didn't have a good plan.
That's a good teaching instructor.
All right, guys, y'all have a good one.